Hello, good evening. As promised, here is just a really quick video. I hope it's going to be quick. Just going through how we can use cast diagrams to find, mainly to change an obtuse or a reflex angle into something that's acute, which we then would extend to which would then extend to finding exact values of specific angles, because obviously your 30, 45 and 60 are all acute angles. We're not going to focus too much on that in this video. It's just going to be using the actual cast diagram, and how you can use that instead of the graphs of sin, cos and tan. It's entirely up to you which one you prefer. Personally, I like the cast diagram, but it is a personal preference. So just really quickly, hopefully we know that the XY plane, so an axis with X and Y positive and X and negative X values and positive and negative Y values, is split into 4 quadrants. We start with the positive X and positive Y, and that's our first quadrant, and then it rotates anti-clockwise around. So we have our first quadrant here, second, third, fourth. Depending on which quadrant we are in, affects the sign of the different trig ratios, so the sign of sin, cos or tan. So if we have a look really quickly at this example, we want to find the sign. We're not finding the exact value, we're not working out what it is, we just want to know if it's positive or negative for sin, cos and tan in the second quadrant. So we are looking over here somewhere. So if we draw in a line, it could be anywhere between, if we say that your vertical Y is 90, and then the negative X would be 180. So we're looking at any angle between 90 and 180 is somewhere in that quadrant, in that second quadrant. Now, remembering that sin is our Y value. I can't remember that I've got that the right way around. Sin is the Y value. Cos is the X value. And tan is the gradient of the line. So looking at this diagram, if sin is the X, it's not though, sin is the Y value, and our Y value is still positive in the second quadrant. So sin theta would be positive. Cos is the X value. We're looking at the negative part of the x-axis. So cos theta would be negative, and then tan theta is the gradient of that line. The line is starting at the top and going down, so it has a negative gradient. So tan theta would be negative. So the only ratio that is positive in the second quadrant is sin, because sin is the Y value and Y is positive, whereas the X part of the axis that we're looking at here is negative. We can extend that to all 4 quadrants, which is where the word cast comes from. And it tells, the letter stands for which of the ratios is positive in that quadrant. We start with cast. The C starts down here, actually in the 4th quadrant, which is pretty counterintuitive. It starts on the last quadrant. If we label in them first, second, we start here and go anti-clockwise. If we're using the cast, we're starting the C here in the 4th quadrant and still going anti-clockwise around to spell out the word cast. Or, as I like to remember it, Sex and the City, as in the TV show, which reads a bit nicer, SATC. It's up to you which one helps you remember it better, but cast is kind of the official acronym to help you remember. And that tells you which of the ratios is positive in each of the quadrants. So in the first quadrant, all of the ratios are positive. The gradient's positive for tan, the x value is positive for cos, and the y value is positive for sin. In the second quadrant, only sin would be positive. In the third quadrant, only tan is. And in the fourth quadrant, only cos is positive, whereas the other two would be negative. And we can use that, and we can use... it's kind of like, what's the word I'm looking for? It's kind of like using vertically opposite angles, and using some like angle rules. But we can use that to determine whether to find an acute angle, to express each of these ratios in. So we're going to change sin negative 100 into an acute angle. And because the sin is negative, the angle is negative, that's why I prefer using the CAST diagram to a graph, to a sin, cos or tan graph. Because if the angle is negative, then it becomes a graph transformation and you're having to reflect the graph and things. If we are looking at a CAST diagram, all it does is change the direction that you are measuring the angle from. So instead of going, like we said in the last video, instead of going from the positive x-axis anti-clockwise, if the angle is negative, we would go clockwise instead. So 100 degrees, we are starting at the, I might use a pen. We're starting at the positive x, and we're going clockwise because it's negative, and we're going 100 degrees, so we are ending up in the third quadrant there, so in the tan quadrant. So if we imagine this is our line, this has, between the y-axis and the line I've just drawn, there is an angle of 10 degrees, because this is 90, and then obviously you've got tan left to take the full 100, which means that this has an angle of 80 degrees, because, again, you've got 90 degrees between your negative x-axis and your negative y-axis. So if we've used up 10 of it, we have 80 left. We can use, because we're measuring that from the x-axis, we're finding an acute angle between the x-axis and the line we've drawn. We can say that sin negative 100 is equal to, almost equal to, sin 80. However, we have to remember the CAST diagram. So this is the T of the word CAST, which means that only tan is positive in that quadrant. So we're going to say that sin negative 100 is equal to minus sin 80, because it has to be negative because of the quadrant it's in, and then the angle 100 will correspond to the angle 80 using angle rules. And now it's an acute angle. 80 is less than 90, so it's acute. I've got quite a few of these to go through, so hopefully it'll help you get kind of the hang of it. They do switch between degrees and radians when they're giving you the angle, so watch out for that, and make sure you're confident with you working with radians. I do tend to still change them into degrees in my head because I find degrees easier to work with, but again, that's a personal preference. You're entirely free to work in whichever you want. If you'd prefer to change your degrees into radians and that's what you're more confident with, go for it, but personally I prefer degrees. So cos 330, it's positive, so we are traveling from the positive x-axis to, in the anti-clockwise direction, 330 degrees. So we're starting here, we're going all the way around. This would be 270, so 330 is going to be somewhere here in the fourth quadrant. Now again, all the way to the negative y-axis would be 270 degrees, meaning that we are left with 60 degrees here. So this part here would be 60, meaning that this angle here is equal to 30 degrees. Now again, we're measuring the acute angle between the x-axis and the line we've just drawn. So we're using that 30, using the cast diagram, this is the C, so cos is positive. So cos 330 is the same, or would have the same value as cos 30 degrees. Okay, so we're finding the angle, the acute angle that is measured between the x-axis and the line we've drawn, and we're just double checking the sign of the ratio using the cast diagram. I hope that's making sense so far. This next one, tan 500. Now obviously 500 is a bigger angle than we've got on the graph. So we would go kind of all the way around 360 degrees. And then we're left with, can't use mental arithmetic right now. 360, we're left with 140 degrees. So we're going to go around 140 degrees, which would be somewhere in the second quadrant. Yeah, you could just take 360 away from 500, but again, personal preference, but I kind of just like to imagine it going all the way around. I don't really know why, that's just the way my brain works. Yeah, but so we would have to actually have an angle of 140, which would take us to the second quadrant. Now again, we've got 90 degrees from the positive x axis to the positive y-axis, which means we are left with 50 degrees here, meaning that the acute angle with the x-axis is 40 degrees. Using the cast diagram, S, this is the S, the second quadrant is S, which means that only sin is positive in this quadrant. So tan 500 is equal to minus tan 40 degrees, because tan is negative in that particular quadrant, and the angle it's making, the acute angle it's making with the x-axis is 40. The next one, we've got 2 pi over 3. 2 pi is 360 degrees, divide that by 3 is 120. So we're doing 120 degrees measured from the positive x-axis in the anti-clockwise direction. So again, that is taking us to the second quadrant. We're ending up over here. This would be an angle of 30, 90 up to the y-axis, and then leaving us with 30 degrees left, meaning that the acute angle that it's making with the x-axis is 60. We want to change that back into radians, because the question was in radians, so our answer should be in radians. Pi is 180, 60 is a third of 180, so it would be the same as sin pi over 6. No, sorry, 3. It's a third of 180. We need to check if it's positive or negative. So in this quadrant, we're still looking at the S of the cast, of the word cast. And again, so that means sin is the only positive ratio in that quadrant. So it is sin pi over 3. It's not negative, it's positive. Right, nearly done. 2 more examples. I hope it's starting to make sense. And if you still prefer to use the trigonometric graphs, then absolutely that's fine. That is your prerogative. But personally, I like this. And then, so cos minus 5 pi over 6. I'm going to change 5 pi over 6 into degrees, because again, that's what I like. So it's 5/6 of 180. Pi would be 180. 1/6 would be 30. 150 degrees. But we're going negative, which means we're going clockwise instead of anti-clockwise. So we're going clockwise 150 degrees, which takes us to the third quadrant here. There's our line. This angle between the y-axis and the line would be 60, because it's 90 up until between the x and the y-axis, which means we are left with 30 degrees here. So that's our acute angle between the x-axis and the line. Using the cast diagram, this is T, meaning that tan is the only positive ratio in that quadrant. So this would be negative cos, and again we need to change our degrees back into radians. So 30, pi is 180, 30 is a sixth of that, so it would be minus cos pi over 6. Yeah. And then the last one, we've got 11, tan 11 over 6 pi. Pi is 180. A sixth of it would be 30. 30 times 11 is 330. Yeah, really doubted myself there. It's 330. We're going around from the positive x, we're going anti-clockwise, taking us all the way to the fourth quadrant. If the negative y-axis is 270, then to get from the axis to our line is 60 degrees, meaning the acute angle with the x-axis is 30. So we're looking at tan 30. This is the C of the cast diagram, so only cos is positive, meaning that our tan value is going to be negative. So we've got negative tan 30 degrees is 30 is a sixth of 180, 180 being pi, so it would be pi over 6 minus tan pi over 6. And that's it. That's the last example. I've got nothing else to add. I hope that makes sense. Like I say, either method works. It's just it's a case of which one you are confident and comfortable using. I like this one, but you might prefer to use the trig graphs and the kind of repeating intervals of the graphs to work out an acute angle. Personally, I like this one, like I said at the beginning, because if I have a negative angle, it means I can just go clockwise around the quadrants instead of going anti-clockwise, instead of having to worry about reflecting the graph and things like that. Not a huge deal, but that, again, it's just more, that's how my mind works, and I find that easier to follow than thinking about the reflection. Entirely up to you. I hope this helps though, and I hope you've understood it so that you can make a decision about which method you prefer. Yeah, have a lovely day, evening, whatever, and thanks for watching. I don't think it was as short as I'd hoped, but when is it ever? Thanks.